Good morning, everyone. Good morning. Hope all is well. Everything's all right. Let's see. All right. Looks like
Good morning.
everybody's in.
Hope you're doing well.
Yes, sir. Yes, sir. Still a little early. Still trying to recover from my 8 o'clock class. But other than that, I'll get rolling soon. Let's see. Let's see. We left off with, I think it was 2.2. I believe it was even and odd functions. Yep, see your head shaking. All right, appreciate it, appreciate it. All right, so any general questions or concerns before we get rolling? We're still in 2.2. We're gonna finish off 2.2 and then get going. Appreciate it, appreciate it. Thank you, thank you, thank you. Appreciate it, sir.
I'm having for the homework for it's I believe one for 1.4. Some of the questions I'm having trouble with.
Okay. Let me ask you this. So you said some of the questions. Is it something that you would like to meet individually and iron out those details?
I'm from like you show like showing me like how to do the like problems like after class.
Okay. Okay. So we'll talk after class then. Make sure you see if we can do it there, or if we don't have enough time, then I'll set up some time with you to meet.
Okay.
Also, I don't know if you guys saw the email. I set some set office hours for anybody who could make those. You can always feel free to jump in on those as well. But yeah, so don't forget, and I was just saying that to everybody, but yeah, don't forget to let's have a discussion at the end of class. Make sure you're good.
I got it.
All right. So starting off with even and odd functions. So here, to test whether you have an even or odd function, we're going to plug negative x into our function. And then from there, if when you simplify it, you come out with your original equation, then it's considered even. But if after you simplify it, it comes out to having the opposite sign in each of one of your terms, or in comparison to your original function, each one of your terms have the opposite sign, then it's considered an odd function. So you're going to substitute in negative x into your function, and then simplify it as much as possible, and finally compare it to your original function to see whether it's odd or even. So looking at this first one, x cubed minus 6x, we're going to plug in negative x, 4x. And so over here, I was just emphasizing the process of when you're having the odd versus the even power. Don't forget, if an even power is applied to a negative, the result will always be positive. But if an odd power is applied to the negative, the result will always be negative. And the reason being is right here, we look at -1 squared, -1 times -1 will give you a positive. So if it's even, that's always going to be the result. But -1 times -1 times -1 will always have an extra negative because it's odd, and the result will always be -1. So down here, if it's -1 raised to the 400th power, the result is going to be positive. If it's -1 raised to the 505th power, because it's odd, the result will be negative. So we're just emphasizing that odd versus even property when you apply it to a negative. So here, when we plug in negative x into the function, negative x cubed is going to result in negative x. Remember, it's an odd power. And then here, -6 times negative x will be positive 6x. So now when I compare this to what I originally had, notice each one of our signs are opposite what the original equation was. And so since each sign is opposite the original function, it is considered odd.
I have a question.
Mm-hmm.
Might be me just missing something, but when you flip the signs on that red example right there,
Right here.
no, the one that you were just
Okay.
the one the blue arrow points to.
Yeah. Uh-huh.
Okay. Why do you flip the sign on the? Why don't you flip the sign on the first to X, but rather take away the parentheses?
Let me make sure I understand what you're saying. You said flip the sign. So this one right here.
Yes.
So when you plug it in, so now when you plug it in, what you have is negative X being Q. So it's negative X times negative X times negative X. And
Okay.
so, yeah, so the two negatives will cancel out, but it still leaves a negative.
Okay.
You see what I mean? So
And that's
right.
why 6 became positive because it was time of negative X.
Well, yeah, right, exactly. So that's negative 6 times negative X, which is just positive X, right? So that's straight, sir?
Yeah, thanks.
Okay. Uh-huh. All right. So everybody good with the odd before we look at this next one. So that's why it's odd, because when you simplify, it will give you the opposite sign to each one of your original. All right. So this next one, you plug in negative X and you raise it to the 4th power, and then you're squaring it. You know, that is our function right there. X to the 4th minus 2x squared. So when you raise it to them even powers, those negatives will cancel. Give you x to the 4th minus 2x squared. And so our conclusion here, notice that this function is the same as the original. So that means it is even.
And may I just mentally go over this for the sake of my understanding?
Mm-hmm.
So the reason why the negative 2x stays the negative 2x is because x to the power of 2 is an even, which would turn it positive, and a positive times a negative equals a negative, right?
Yes. Mm-hmm.
And the reason why the 4 becomes positive, the same as the original.
Yes.
All right.
Mm-hmm. All right. Anything else before I scroll up? Do the next one. All right. When you say the top, are you talking about right here? Let's say, can you see the top again? All right. So for Imani, I don't know how far you went. Let me see. All right. So, goodness, you needed that. Not a problem. All right, so let's look at C. So the first one was odd, second one ended up being even. And so let's look at this third one. We have x squared plus 2x plus 1. Once again, we're plugging in negative x to, and then simplify. Then we'll do our comparison to our original function. So negative x squared is just going to be positive x squared. You know, negative to a negative turns positive. And then here, that's just 2 times negative x, which is negative 2x. And when you look at your conclusion, remember, you always compare it to your original. Comparing this to this. So all signs are not the same. Neither are all signs opposite. So this function is neither odd nor even. Because remember, the option was odd, even, or neither. So this one would be neither. All right, problems, questions? Can I scroll up? Are you good with that? All right, so the next thing is the difference quotient, last thing out of this section. Difference quotient. Now, it's actually something that you'll use in calculus, but they introduce it here, so it's not your first time that you see it when you get to calculus. So we just calculate the difference quotient, but we don't actually use it in any type of application. It's something that we will use in calculus to be able to find this slope of the tangent line. But like I said, you'll see that later on. So we have f of x plus h minus f of x over h. So how much of a process this is always dependent upon how complex the equation is that you're dealing with, how complex f of x is. So f of x here is 2x squared minus x plus 3, and we want to find the difference quotient. So notice they give us f of x. So we have f of x, but we need to find f of x plus h. We need an algebraic representation for f of x plus h. So we're going to take f of x and plug in x plus h wherever we see x. So we know we had 2x squared minus x plus h. Okay, not a problem, not a problem. Thanks for letting me know. So now we have 2 times x plus h squared minus x plus h plus 3. So you want to expand this out as much as possible, simplify as much as possible, combine whatever like terms you have before you go plugging it back in here. So we expand x plus h times x plus h and FOIL it out, and then also distribute the negative into the parentheses of x plus h that follows that. And so that's what we have here. And so giving us x squared plus 2xh plus h squared. Multiply that times 2. And so this is what we have, 2x squared plus 4xh plus 2h squared minus x minus h, and then that plus 3 is still back here. All right, give you a chance to copy that down. All right, so now that we have an algebraic representation for x plus h, we can go ahead and plug that into our difference quotient formula right here. So first parentheses is f of x plus h. Then I put a little arrow there just to signify where the minus sign lines up with the formula minus sign. And then f of x is in the back. Get rid of this purple. All right, and all of that is over h. Everybody okay? Distribute that negative. And now some terms are going to cancel out for us. We see 2x squared will cancel, x will cancel, and the 3 will cancel. So now what happens next is that everything should cancel that does not have an h. All right, can I scroll up? Should be okay. So each term left will have an h in it. In other words, each term left will have an h in it. That has to happen if when you go canceling out stuff and you one of your terms don't have H, then you need to go back and check that this is what must happen. This is what will happen. Each term left will have H in it after you do your cancellation. What's going to happen is that H has to cancel out into each term because when you in calculus doing this, using this process, H actually goes to 0. So you know we can't have 0 in our denominator. And so that's why this H has to cancel out. So when we go to evaluate, there will not be a 0 in our denominator. But like I said, that part is in calculus. This part right here, just know that each term has to have H in it so that it can cancel out completely. And what we're left with is 4x plus 2h minus 1. So there's an h left in, with that 2h term because it was 2h squared. But that's fine as long as h is not in your denominator. Still have my eraser. If I put a 0 right here, 2 times 0 is just 0, so that's fine. But what we did not want was h in our denominator. So that would be your difference quotient. All right, so any questions on what we did before we do another one, just to make sure we're all right? Mr. Bracy shaking his head no, so I'm assuming that means he don't have any questions over there in his Jedi outfit. Obi-Wan Kenobi. Let's see. Everybody good before we go to this next one. Now this one is as less involved, not as involved, I guess I should say, as the last one, just because it's not as complicated, but it's the same thought process, same procedure that we'll go through. And like I said, just want to make sure we're okay with the process. So we have f of x is equal to 3x plus 7. So we have f of x that has to be given to us originally. And so now from there, we will plug in x plus h because we need a representation of f of x plus h. And so this one, oh, somebody said something. Yep, I was actually thinking about that. I was like, "Dang, man, I wonder how would I feel if I had like," I was actually thinking about it. But yeah, so distribute the 3x plus 3h plus 7. That's all we have to do here. And that is our most simplified way of expressing f of x plus h. So then we go ahead and plug it in. F of x plus h minus f of x. Distribute that negative. We see 3x cancels and the 7 cancels, leaving us with 3h over h, and that's just 3. Any problems? All right, so that's it for 2.2. Before we go to 2.3, can I go to the next page? But still copying. All right. So 2.3, linear functions and slopes. So we're going to introduce slopes. So your slope is going to be represented by m. And that's going to be calculated by y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. So we can do it either way. Just remember, you have to be consistent in what you're doing. If you're going to use y2 first up top, make sure you use x2 first down bottom, or You use y1 first up top, make sure you use x1 first down bottom. And then we have rise over run, which we'll use when we actually graph using our slopes. So x1, y1, x2, y2 represents 0.1 and 0.2, and they just represent any 2 points on the line. So your slope is exactly what it sounds like the slope of a mountain, slope of a ramp, or a roof. It's just the incline, a numerical value for the incline or the steepness of your slant. So first exercise will be find the slope of the line passing through the points. So on this first one, it's the only one I'll do it this way. I'm going to do both of these just to show you that either way you'll get the same answer. But of course, when you're doing it on your own and from that point forward, I'm only going to do it one way. Because like I said, either way you'll get the same answer. All right. So we have the 2 points, -3, -1, and then -2, 4. All right, can I scroll up? All right. I always label which one I call 0.1, which one I call 0.2. Normally, the first one I see is 0.1, second one is 0.2. It doesn't matter which one you do. Like I said, as long as you stay consistent in your substitution, you'll be all right. So I'm going to use the first way first. Y2 minus Y1 over X2 minus X1. Y2 is 4. Y1 is -1. So make sure you don't lose a negative here. There's a minus sign in your formula, and you're plugging in -1. So sometimes people do lose a negative when they're doing their substitution. Make sure you don't do that. You lose a minus sign in there, then most definitely you'll get the wrong answer. Then X2 is -2, X1 is -3. Once again, be careful with your negative signs. So negative to a negative turns positive. That's why I circled those. 4 plus 1, -2 plus 3 gives me 5 over 1, which is equal to 5. All right, any problems with that? So here,
Hey, do you mind walking through that one more time? Because I was copying and did not watch anything that you just did.
yeah, not a problem. I was wondering where you at, man. Heard from you the last couple of days. I know you've been in class, but I hadn't
Oh,
heard-
nah, man. I was sick as a dog Monday, man. I was fighting to stay in here.
Oh man, oh man. Sorry to hear that. Glad to hear that you're doing a little better, if not all the way. So y2 minus y1. So we getting these points from right here. I called my first point x1, y1, second point x2, y2. So don't forget your first value is always x, second value is always y. But if that first one is 0.1, that's x1, y1. Second point is 0.2, x2, y2. So y2 minus y1. So it's 4 minus -1. So that's what we did here. And then x2 minus x1. That's what we did here, -2 minus -3. Negative to a negative in both cases turns positive. So that's 4 plus 1, -2 plus 3 down bottom. And that gives me 5 over 1, which is just 5.
Thank you.
Yep, not a problem. Next one, same points, same process, except I decided to go ahead and switch. Remember I said that as long as you stay consistent. First one I did y2 minus x2. And the second one I'm going to do y1 minus x1, just to show you that you'll get the same result. So y1 is -1, y2 is 4, so that's -1 minus 4 on top. On bottom, we have x1 minus x2, that's -3 minus -2. So if you were to do the calculation, that's -5 over -1, which is still +1. So once again, either way, you get the same result. You just have to be consistent in your substitution. Let's scroll up, do another one. Everybody okay? All right, so next one, -3, 4, 2, -2. First point, -3, 4. Second point, 2, -2. Plug those in accordingly. So y2 is -2. Y1 is 4. So that's -2 minus 4 on top. X2 is 2. X1 is -3. So 2 minus -3 is going to be +5. And I can't reduce that any. And we leave it in fractional form. So it's -6/5. Questions? Any questions on that? All right. Very good. So we have 4 basic behaviors of our slopes. And you always read your graph from left to right. So from left to right, if your graph is going up, your slope is positive. If it's going down, your slope is negative. If you have a horizontal line, your slope is 0. If your line is vertical, your slope is undefined. So those are your 4 basic behaviors of your slopes. Any problems? All right, can I scroll up? All right, so graphing using our slopes. Remember I told you we have that other piece of our slope represented by rise over run. At least I thought I said that, but I know I wrote it. Anyway, so rise over run, we use that when graphing. And so we're looking at that now. Your rise is going to represent your up or down move, your run, right or left. And so what will dictate whether we go up or down versus right or left, or up or down or right or left when we talk about down. All right, so let's say something in the chat. Yep, exactly. Yep, because we have the change in y up top over the change in x. Yep, absolutely correct, sir. Y2 minus y1 over x2 minus x1. So what's going to dictate whether we go up or down, and then right or left? Well, if we have a negative or positive number. So our positive moves will be up and right, negative moves will be down and left. All right. Stay right there. So just examples of what we mean by that. If I have 2/3, that's a +3. I said +3, +2 over a +3. So both of our moves are going to be positive. That means I will go up 2 and then right 3. So your vertical move, your rise is your first, your top number, and then your run, your horizontal move will be your bottom number. So we have 2 positive moves here that will be up 2, right 3. Then the next one, -10 over 7. So we have to be careful here. So your fraction is negative, but both numbers aren't negative, because if both numbers were negative, then that would be positive. You know, negative over negative is positive. So you just have to make a decision on where you're going to assign the negative. I always say just give it to the numerator, but if you decide to give it to the denominator, that's fine. You still will get the same line. So what do I mean by that? If I have negative 10 over positive 7, that means I would go down 10, right 7. Or I can do positive 10 over negative 7, but that means up 10, left 7. So if this is my point right here and I go down 10, right 7, I create that line. But if I go up 10, left 7, I still create the same line. All right. So it doesn't matter which one you do. You just have to make sure you don't give the negative to both. Just give the negative to one of them and then apply the directions accordingly. Questions on that? Can I scroll up? So before we graph, we're also going to look at the slope-intercept form. That's y equal to mx plus b. Wherein if you solve your equation for y, that's why I have the little arrow on y. If you have y by itself on one side of your equation, what's attached to x or what's sitting in front of x is your slope, and then the other number is your y-intercept. So here's the first one. If I have y equal to 2/3 x minus 1, what's attached to x is my slope. So 2/3 is my slope. And the other number, which is -1, is my y-intercept. All right. And then here, if I have y equal to -4x plus 3, the -4 is my slope, and the 3 is my y-intercept. All right, so how does that help us? Go ahead and graphing. Let's try to graph that y equal to 2/3 x minus 1. Can I scroll all the way up? All right, so we've already established that our slope is 2/3 and our y-intercept is -1 for that equation, that function. So if it's +2 over +3, that means I'm going up 2, right 3. That's my directions for my slope. And I'll hold on to the fact that your slope is not a point, it's a set of directions. Okay, talk about that in a second. And your y-intercept is -1. But don't forget, we talked about intercepts before. All right. X is equal. No, it's not 0 over 0.66. It's just 0.66. If that's what, hold on. Yeah. Because now if you're talking about x equal to 0, we're talking about in the terms of your y-intercept. If I'm calling this my y-intercept, the coordinates of it is going to be 0, -1. So then if I were, so in other words, if I were to plug 0 right here, 0 times, okay, I see what you're saying now. It wouldn't be, it would actually be 0 times 0.6.
It would be,
It wouldn't be 0 over 0.6. It would be 0 times 0.66.
okay, so when you say y-intercept, you mean the y, right?
Yeah. So when you say y-intercept, that means x is 0. And when you plug 0 into your function, x is 0. And then what's left is your y as far as your coordinates is concerned. So that's why I was saying, that's why I didn't see when you said 0 over 0.66, is actually 0 times 0.66.
But I was saying switch it around to solve for the x. Like if you wanted to solve for the x, you would have the y on the other side. But since we already have the y defined, it would be -1 +1, which equals 0. and then divided by
Oh,
2 divided by-
you're talking about if you were trying to find the x-intercept.
yes.
Okay,
The
yeah.
Y-intercept is given.
Yeah, but we don't need the x-intercept in this case. Yep, I see what you're saying now. Yep. All we need is our y-intercept, and then these directions are going to give us another point. All right. So everybody good with that part? And I'm going to erase this. So directions here. First thing we're going to do is graph the y-intercept. So our y-intercept is 0, -1. That means we don't go left or right for x, but we just go down 1. And so that's that blue point for us. And then from the y-intercept, notice that we don't go to the origin because this is not a point. Those are directions. But I know people have done it in the past. I'm trying to address it, try to cut it off at the pass before anybody does it. So up to right 3 is not a point. That's a set of directions. So you go to your y-intercept and go up to right 3. So you're going to generate a point from the y-intercept. And that's that point, that purple point right there. I went up 2 and then to the right 3. And once you have those 2 points, you have your line.
So wait, are your increments those lines, are those increments of 2 then
No,
on the y-axis?
no, you start right here and you count the origin line, and then you go to what you go basically go up to 1. Yeah.
So I thought that was 0 though. So 0
Yeah.
doesn't have a property then?
Yeah, you go up that, so you're at -1, right? Then you go up to 0, and then you go up
Okay.
to +1.
Okay, I got you. That's why you said graph the y-intercept first. Okay, I'm with you.
All right. Anybody else? Make sure we good on the directions. We'll do another one, but I want to make sure we're okay with this one. So like your classmate just mentioned, grab that y-intercept first, then from the y-intercept, here we went 1, 2, and then from there we go 1, 2, 3, which is put us at this purple point. Yeah. If m is equal to 3, does it mean go up 3? Yes, if m is equal to 3, that means that's a fraction, that's 3/1. So right, you would go up 3 and then right 1. Add 2 to the negative, and 3 plus 0. So you got 3, 1. Oh, you're talking about the change to go to 3, 1? Yeah. Yep.
All right. I'm trying to figure this. I'm sorry, I missed the beginning. My internet's acting up. I'm relying on my hotspot on my cell phone right now. The y-intercept. So I totally get how to graph the 2 and the 3. But how are you getting the y-intercept? Like if you just point like where it comes out when you have that line graphed, I think I can connect it.
Now where you got it from is this -1 right here. Are you talking about the fact that it's -1 or the fact that we have this ordered pair?
That order pair.
That came back. That was a recall from last class when we talked about intercepts.
Okay, yeah, I'm still lost on that one. I'm waiting for the.
So
All right.
y-intercept, if you have a y-intercept, x is always 0 as far as that coordinate is concerned. So that's just a characteristic of all y-intercepts. X is always 0. So if I tell you -1 is a y-intercept, that means the coordinate of that is going to be 0, -1.
All right, my next question is your office hours today. Are you like available? Because I'm gonna need a lot of help.
Yeah, I should be there.
Okay. So you just like click on the link and show up? Is that how the office hours works? All right, cool. Thank you.
Does that mean x is always going to be after m? So, and there'll never be like x 2/3 minus 1?
Yeah, no, this is the normal way of writing that. Yes, it should,
Okay.
that would be a weird way of seeing it, even though x times 2/3 is the same exact thing, that would be a weird way of writing it. Normally that's never the case.
Okay.
All right, so let's do it again. Here we have -5x plus 4. That's equal to y. So m is -5, but as a fraction, that would be -5/1. All right, and then your y-intercept, the value that's by itself, or in other words, not attached to x, is 4. All right, so you got -5 over +1, so we go down 5, right 1, and then just like before, y-intercept means that the coordinates is going to be 0, 4. Graph 0, 4 first, so that's on your y-axis. And you see that we went up 4. And then from the y-intercept, you go down 5, right 1, and that is that purple line, or purple dot right there. And once you have your 2 points, connect the dots. All right, questions, any questions?
So for M, you basically always want to, I guess, have a fraction so you could go the 2 directions.
Yes. Mhm.
Will there ever come a time where you have to do anything with that fraction for M?
When you say
Like
do
simplify
anything,
it, yeah, like simplify it
um,
or multiply
mm,
it or anything like that, or is that pretty much just going to be what you're going to use for the standard across the board?
that would be pretty much it. Now you
Okay.
can, if you have 4 over 6, you can simplify it to 2/3 before you do any directions with it. But other than converting it, you wouldn't convert it to a decimal or a mixed number or anything like that.
Right, but I guess what I'm asking is if you do simplify it, is excuse me, is Math Lab gonna recognize that as the proper answer, or are you
You
gonna
said
have
if,
to get it? Yeah, will Math Lab recognize it if you simplify it and then try to graph it that way?
yes, it still should be the
Okay.
same thing. Mhm. All right, so let's look at the point slope formula. This is the last thing they talk about in this section. And that's y minus y1 equal to m times x minus x1. I'll scroll up. Everybody done with that last one? So it's called the point slope formula because you need a point and a slope. Just any point, doesn't have to be at any specific point. Any point on the line and the slope, and you will be able to create the equation for that line. So notice we're plugging in for y1, m, and x1. Y and x should still be a part of your equation. If you go back here and notice y and x was still a part of the equation. Excuse me. So we're plugging in for x1, y1, and m. So we want to write an equation for the line that passes through -1, 3 with the slope of 4. All right. So that means m is 4. x1, y1 is -3 and 1. Yep. So we substitute in for y1, which is 3, m, which is 4, and then x1, which is -1. Make sure you don't lose that negative. There's a minus sign in the formula. You're plugging in -1, so it should be a double negative there. Negative to a negative turns positive. And we distribute. So this y minus 3 equal to 4x plus 4. And then to simplify it all the way, we'll add 3 to both sides. Y is equal to 4x plus 7.
Why do you use that last x instead of the first one?
Now, when you say last x instead of the first one, now we talk about
Yeah, so it's a
substituting.
formula. Yep, that's the
Yep.
one.
Yep. So that's what we're doing for even when it comes to the y. This point is considered x1, y1, not the x and y. So that's what we're substituting in for. And we want to
But
keep.
wouldn't that be x2, y2? Because that's the second y and the second x.
Well, you would call x2, y2 a second point. So if we had a second point that was
Okay.
introduced, let's say if it passed through -1, 3, and then 2, 4, then this point we could call x2, y2. Should mean that would
Okay.
be represented by a second point. Yeah.
I got you. Thank you.
Mm-hmm. All right. Everybody good? Are they okay before we do another one? Okay. Next one, write the equation of a line that passes through 8, 5 with the slope of -1/4. So this time they give us a fraction for our slope. All right. So slope is -1/4. X1, Y1 is 8, 5. Plug in accordingly. Once again, we're talking about Y1, M, and X1. So plug in 5 for Y1, -1/4 for M, and then 8 for X1. Then we distribute that -1/4. So I tried to show the work up here as to how you would take care of that. -1/4 times X is just -1/4, but then when you multiply it times 8, if you want to reduce first, you could, but I just went ahead and multiplied across. That -1/4 times -8/1 is just 8/4, which is 2. And then you can finish it off by adding 5 to both sides. So y is equal to -1/4 x plus 7. All right, questions. All right, can I scroll up? Oh, that's it for that section. Everybody good?
Scroll back down just a little bit for a second. That's good, right? I'm good. Thank you.
All right, not a problem, not a problem. Everybody good before we go to the next thing? Oh, my screen right. Okay. So 2.4 is short. It just piggybacks off of what we just finished talking about as far as slopes are concerned. Just introducing parallel lines and perpendicular lines and their relationship, their slope relationship. So we can knock this out real quick. Yep, it's 10:22, so we got a little time. So parallel lines are lines that do not cross or touch. They have the same slant or incline. So that means the slopes will be the same. All right. Perpendicular lines, they intersect at a 90-degree angle. So there are two lines that intersect at a 90-degree angle. And their slopes are negative reciprocals of each other. And we'll talk about what that means in a second, just to make sure we're okay. All right, scrolling up. So let's make sure we're okay with what it means to be a negative reciprocal. Reciprocals are just flipping the fraction. So that's the first column. So if I have 3/4, flip it, that's 4/3. That's reciprocal. No calculation, just flipping the fraction. Everybody okay with the black? Same thing with -10/7. You just flip it, keep the same signs, -7/10. And then even if I have 5, flipping it would just give me 1/5. But when we talk about perpendicular lines, we want negative reciprocals. And mathematically, that just means opposite. So you want to flip the fraction and use the opposite sign. So 3/4, the negative reciprocal of 3/4 will be -4/3. For -10/7, the negative reciprocal is 7/10. Once again, we're talking about the opposite sign and then flip the fraction. And then for 5, that will be -1/5. So for perpendicular lines, we want the negative reciprocal, the opposite sign, and you flip the fraction. All right. Is everybody okay with that? So parallel lines have the same slope. Perpendicular lines, their slopes are negative reciprocals of each other. All right. In the red, we're just going to reinforce the relationship, make sure we're okay. Now scroll up. Oh. Okay. So looking at the first column here, if the slope of my line is 8/3, and I want a line that's parallel to it, that slope will be 8/3 as well. Remember, parallel lines will have the same slope. Okay. If my slope is 8/3, but I want a line that's perpendicular to it, I'm going to flip the fraction and use the opposite sign. So that's how I got -3/8. Okay. Second column, same thought process, but this time the slope of my original line is -9/11. So if my slope is -9/11 and I want a line that's parallel to it, then that slope will also be -9/11. But if I want a line that's perpendicular to that, I'm going to flip that fraction and use the opposite sign, which would be +11/9. All right. Questions on the relationships? Is everybody okay? All right, scroll up. So let's use this and then do 2 examples and that'll be it for today. So it says write the equation of the line passing through -3, 1 and parallel to y equal to 2x plus 1. All right. So we have this point that this line passes through, and we know that it's parallel to this equation right here. So if it's parallel to that equation, then I know that the slope has to be the same one as that one. So what I'm going to do is find the slope of that line. And we, because it's in y equal to mx plus b form, I know it's attached to x is my slope. So that's the original slope that we're looking at. And then a line that's parallel to that is going to also be the same thing. So that's going to be 2. And this is the slope that we're going to use. We want a parallel line. So we want a line that's parallel to that line. So we use the same slope. So before we go any further, is everybody okay with what we've done? All right, cool. So now we're going to lean on what we did in the last section, with. We have our slope and we have a point. So we use the point slope formula to find the equation of the line. So y1 minus y1, y minus y1 equal to m times x minus x1, and we plug the values in accordingly. 2 for your slope, which is m. 1 for, well, I did it backwards, but -3 for x1, and then 1 for y1. So we plug our values in accordingly. All right. So don't forget, negative to a negative turns positive. So that would have left us with y minus 1 equal to 2x plus 6. Then go ahead and add 1 to both sides. Y is equal to 2x plus 7. All right, any problems before we do one more?
Would you care to repeat that last part a bit? So if I'm getting you correctly here, you use the parallel slope. You were like, okay, parallel, that means the slope's the same. Then you plugged in that slope to the y minus y and x minus x sort of thing. And using that, you got the formula which determines the y and x. Or you got, better yet, the slope, not the slope, the formula for the next one, for the other line.
Yes, right. Oh, my eraser was still on, sorry. But yeah, right. We got the equation that fits the description of the problem that they gave us. Yep.
The start's just one line up ahead of it at 7 up.
Say the last part again.
That +7 right there is the Y-intercept, right?
Yes.
So that means it started like just the line ahead of it, parallel.
Yeah. So yeah, you could actually start there at 0, 7, and then create that line. Yep. All right, everybody okay for one more? Everybody good? All right. So this time we want to write an equation of line that's passing through the point 3, -5. Excuse me. And it's perpendicular to x plus 4y minus 8 equal to 0. Then it tells us to express in general form. We'll talk about that when we get to the end. But let's look at actually finding the equation first. So just like before, we need a slope, and we need a slope of this line so we can determine the slope of the line that we're looking for. So we're going to take that, and this time, now the last one was already solved for y. So we didn't have work to do there. This one, we have to solve this equation for y. And this is what I'm doing here. The original equation, x plus 4y minus 8 equals 0. I need to take my terms that do not have anything to do with y to the other side. So I subtract x, add y. And that actually gives me 4y equal to -x plus 8. Subtract the 8, add a y. Now to get y off of, get 4 off of y, we divide both sides by 4. And that gives me -x over 4 plus 8 over 4. And then of course 8 over 4 is 2. So that's not our equation that that's gonna, that we're done. We're not done. That is just this equation solved and or put in Y-intercept form. All right. So now we know what the slope is, because remember, once you put it in Y-intercept form, I said Y-intercept should be slope-intercept. Sorry about that, slope-intercept form. Once you put in slope-intercept form, you know what the slope is because that's what's attached to x. So our slope is -1/4. But we want a line that's perpendicular to that line. So the slope we're going to use is +4/1, which is just 4. So make sure we see the connection, because I know a lot of times when people do these problems, that slope piece gets lost in the process. And if you don't have the right slope, of course, you won't have the right equation when you go to find the answer. So make sure we're clear on what we did. First thing we did was we solved the equation for y. We got the slope from that equation. Now, that does not guarantee that's the slope we're going to use. It's all based on what they're asking for. If it's parallel, we use that slope. If it's perpendicular, you use the opposite sign, and if I can say it out, opposite sign, and flip the fraction if it's perpendicular. So that's why we have a +4 here. All right, so let's finish the problem off. We now have our slope, which is 4, and our point was given to us, x1, y1, 3, -5. And we can plug into our equation, our formula. All right. So we have a double negative there, y minus -5. Make sure you turn that to a +5. Distribute the 4. So we have y plus 5 equal to 4x minus 12. Then to simplify it as much as possible, we will subtract 5 from both sides. Y is equal to 4x minus 17. All right. So remember, the last thing they asked of us, though, was to put our equation in general form. So general form. Now, once again, they'll tell you if they want that. So if you don't see that, then y equal to 4x minus 17 is fine. But they said put it in general form. So that's ax plus by equals ax plus by plus c equal to 0. So that means all of your terms are just on one side of the equation. So all we have to do is subtract y from both sides. And 0 is equal to 4x minus y minus 17. That's our answer. And that should be it. Yep. So questions on that. All right, everybody good, everybody straight. All right, so as always, try this stuff out. Make sure that you don't have any questions. And as your classmate mentioned, I did send some office hours out. I did send some office hours out. So feel free to come to those. Of course, if you can't make those, then shoot me that email so we can set up a time that we can meet. Also, when you do come to anything we set up or any office hours, make sure you have your problems already lined up so we can just go ahead and attack your issues versus looking for problems, when you come. So make sure you have them lined up because, if you come, then, never know if somebody else will be there as well because it's not office hours just for one person. Those are just general office hours. So, we can address multiple people at the same time as long as everybody bring their stuff ready to go when you get there. So any questions before we close out? Any questions?
Yeah. It's from homework 1.4. There's this one question I'm having trouble with.
Okay. So let me say this. If you are done and everybody's good to go, that's it for today. I'll see you next class. Have a great weekend and be safe. Be safe. Yep, thanks. You do the same.
Have a good one.
Work yourselves. See you
Thanks.
later.
Thanks. Take care. You do the same. Yes. You have a good one as well. So, Mr. Logan, you know what? You said 1.4.
Yeah.
And you know what type of problem it is?
Yeah, it's just basically it's to simplify the answer into like a plus bi, and it says subtraction.
Okay. So did you have one in particular, or you just want me to make up one?
One in particular.
Okay, what you got?
It's 8 minus, then it has parentheses minus 3 plus 5i, then parentheses close, then minus parentheses 8 minus, and negative 8 minus I in parentheses close, then equals.
Okay, so make sure I got all my minus signs and everything up there correct.
Yep.
Is that exactly? Okay.
That's correct.
Okay, so what you're going to do first is distribute the negative to each. So that's going to change the sign of each one. So that'll be a positive 3 minus 5i, positive 8 plus I.
Okay.
And then from there, you combine your like terms, combine all of your reals. So 8, 3, and 8 will give you, what's that, 16, 19. And then negative 5i plus I will be negative 4i. And that's all you need to do.
Okay. Thank you.
Not a problem. Not a problem.
I don't have a specific one in mind, but factoring the cubes. Can you walk through that, man? Because that is just kicking my butt.
Remind me next class, because I'm pretty sure somebody else wanted. And it's a longer process, and I got to get ready to go to this next class.
Okay.
So because that's
is it cool
actually,
if I jump in on that office hours this afternoon and you walk me through it so I can just start banging out my homework on that one?
Sure, for sure. Because and the reason why is because it's an actual formula, and you may have questions.
Oh, I'm definitely gonna have questions, bro. Don't worry.
You know what I'm saying? So so yeah. So that's an actual, formula. So I want to make sure you got all the, all the information you need before I let you go. So yeah,
absolutely.
Come through today and we'll make sure you're straight.
All right, man. I appreciate it.
Yeah, not a problem.
Yeah.
Y'all have a good one. I'll see you later.
All right, y'all take care.
See you later.
All right, real quick for me, because you said mention about having your questions, your problems, and lined up. I don't have specific problems. It's more like, how do I do it? Period.
So go into that section and pick out a problem or two or however many that you want to see me walk through. Like if you're looking at it and saying, okay, I don't know how to do that, then bring it. Then that's how we'll address it. And then make sure you're okay with the process. So,
But if I'm not even sure on what I don't understand, though, that's the thing.
well, then that's a clear indication. That's a problem. Yeah, if you
Okay.
look at a problem and you say, I don't know what to ask, then that's
Okay.
a problem that we need to do.
Okay.
You know? And then if while we're doing it, you end up, oh, that's all. Okay, then we know we need to go to the next one. You know what I mean? So, you know, if you see a problem and just off the jump, you're like, man, I don't even know what to ask. Then that's a problem you'll bring and we'll knock it out.
Okay, because I'm really good at graphing, but now I'm like, what the hell? I think I forgot everything.
And it might be one or two things, like something simple that you're like, oh, okay, I didn't make that connection. Then once you get that connection, the light bulb go off.
That's what I'm hoping. So I'm trying not to freak out. So, yeah. All right.
Yeah,
Well, I'll see you this afternoon. Thank you.
All right, sounds good. All right, bye.